welcome to ToddFun.com, where I do what I think is fun. And today, I'm going to see if I can fix this timer. This is a timer I use for my main Christmas lights outside. It's supposed to, it actually has a sensor that senses when it's dusk, and it turns the lights on, and then you set it to how many hours you want it on, and it turns off after that many hours of being dark. And my lights were on all the time, 24/7. So I thought I just didn't have this set right, but I actually went out and checked it, and it was set to 6 hours, so it was fine. But even when I turn it off, like right now it's off, even then it would still be on all the time. So obviously this is broken. What I expect to find is there's a relay inside that the timing circuit is controlling. Those relays are controlled with usually like a small transistor, possibly a surface mount transistor. And I've seen problems like this before where the controlling transistor it's either blows open and means it never comes on because it can't turn the relay on, or it'll actually fuse closed internally. That transistor will be a dead short all the time, and hence it wants the relay on 24/7 as long as this thing has any power at all. And so that's what I expect to find. So let's get inside and see if we can find the problem and fix it. May or may not be that. Well, this might be a bit tricky. I don't see any screws. Well, as Photonic Induction Channel would say, I had to get my hammer because this thing was essentially glued all the way around, I suppose because it has to be watertight. You know, it's an outdoor controller. So I just got my hammer and I just went along the edge and just kept whacking the edges until it kind of popped all those plastic glue joints. So we got a ground wire coming here, and then you got neutral going this way, power on that side. Okay, interesting. Sort of a water sealed rotary switch here. With that little block goes into this little hole here, so that when you turn the outer dial, it's a watertight seal into this turn the switch. There's the relay that we'll know that turns the 120 volts AC on and off. And well, there's a transistor. That transistor right there at the bottom is all bubbled up. It's fused closed inside. It'll be a dead short now. And this relay's on all the time as long as this thing is plugged in. So that's our problem. If we can fix that, it's not even surface mount, so this should be pretty easy to fix. If I can identify the type of transistor that's being used here, something close enough, we'll have this fixed again. And then of course I'll have to glue it real good so that it's water sealed again. Okay, I got the board mounted in my little bench vise here, and we need to get the solder off of the back of the transistor, which the emitter, collector, and base come out right here. I've got solder wick, which is this is actually a desoldering braid. I think I got some resin core stuff too. That's even better than that. I do have a solder sucker. If you keep these really clean, in fact, let me show you a real trick with these. If you use these, you may get frustrated with them when they don't work, and that's because they get dirty inside. And so when you keep these clean, they work really well. They produce a big vacuum. If you can see there, you get solder gook on it, and you got to get that out of there. You got to get it out of there. It gets inside of here, gets all over your spring. You want to get as much of that off as you can. Pops out like that. This double O-ring area, it gets all that solder built up on it, and then you don't get good vacuum. And that's what frustrates people with these things, is when they get dirty. So before we use ours, we'll take a moment, we'll clean it all up, make sure it's clean inside, wipe this all down real good. And I like to take a bottle brush and bottle brush inside real good, get all those flakes of solder out. Screw that back on. Get some Vaseline on those O-rings real good. There's one down here too. Drops back in there with the tip pointing up, because that's what actually cleans your plunger area. That's where the tip that comes out cleans that channel. And then your spring goes in. And this is the tip, but these tips are replaceable. If you melt this tip a bit too much, you can just screw on another one of these tips. They're pretty common. I got this model at Radio Shack. It's all metal. I like it. In fact, it's all metal. It has double O-rings in it. I really like that. It makes it a lot more durable if you drop it and everything. And we're going to show this working, and we're going to show this working because there's 3 leads to do. That's 2. The third way we're going to show is we're going to show this bad boy. This is a hot iron desoldering wand. It's not a desoldering station. It's just a wand, and the tip gets hot, and it has the same plunger mechanism that you saw with the other handheld one, and it just does the same thing. It sucks up. You got to clean this too, but it comes apart pretty easy too. You just grab the thumb and this just pulls off, and all this comes apart. I've already cleaned this one all up. It comes apart pretty much the same way, but this is all plastic, so it's a little more delicate. Don't drop it. And the only other thing you have to clean with this model, and these work really good because they got the you don't have to have a separate soldering iron. You just use this alone. It's the plunger and the solder sucker at the same time, and you got to stick this this cleaning rod that comes with up inside, and that cleans out. It'll get clogged in there. This gets hot, by the way, and you just give that a few good pulls, and it'll pull that solder out of that nose for you if it gets clogged up. So let's show this one first. I'll zoom in a little bit here first to show what I'm working on. These 3, 1, 2, 3, those are the back sides of the emitter, base, and collector, and they're labeled on their side. That's going to make it easy for us. But those leads are a little bit long. They didn't trim them good, so I'm going to start by making sure they're trimmed really short, and that'll make it easier to pull it out once we get it hot. Technically, being this is a single part, I could just heat all 3 spots with just an iron, just put an iron across it, and just pull it straight out the other side. But I want to get the solder out, and I want to show how this tool works. So, being this tool actually heats at the same time as solder suckering, I just make sure the plunger's ready. Like that, so my plunger's ready. I like to use this tinning cup. It's just a little can of Radio Shack. I can't zoom in on that, can I? And it's just Radio Shack tip tinning, and that's a real quick way to just you just do that. You just stick it in there, and it gets your tip really clean, and you're there. Whoops, there you're ready to go. And then, of course, a little bit of a brass cleaning. Got too much of a close-up going on here, but your brass cleaner, and you're ready to go. So let's see if we can see this working. I'm going to try and do this first part. I get it on there. I let the heat melt the solder. Swirl it around a little bit, little circles, and then I pop, push. There, I don't know if you can see it, but it pulled that solder out pretty darn good. Probably all of it. So we'll move on to the next way. Okay, the next one is just a regular soldering tip. Once again, I'll start with my tin, and I'll go ahead and tin that. You could just use regular solder to tin this too, that's fine. And then my big cup of brass cleaner. You could use a wet sponge too. Wet sponges work too, but I like these brass cleaners. Some kind of brass, I guess, brass shavings. And so this time we're going to do our braid. Start with a fresh piece. Get that joint good and hot. And then I'll see if I can get that to suck up better. I turned my iron all the way to max. I just want to really suck that solder out of there. Wick it up with the solder wick. There, that did a pretty good job. You can pretty much see all around the joint now by turning the heat up on this iron to totally max. This is another one of these mechanical ones. This is not a self-heating one, so you have to heat the joint with this yourself. And you gotta kind of have a little bit of a flip of the wrist. So you start by cocking it, you get the joint really hot, and then you just got to be quick. You got to cover that joint with that tip, and then push that plunger button really fast. And you'll melt your tip a little bit, but the trick is to do it before the solder solidifies. And a lot of times I got to do this a couple times. So we flip it around, and then this is the part we were trying to get out, and we should have desoldered it by now, and it should pull out now. There, see? Pulled out. Now we got to check to see if we can get the specs off of this thing. Okay, look at that. We got our numbers on our transistors. We'll be able to look that number up on the data sheets at toddfun.com. I have beginners for electronics section at the top, and I have links to things like chip finders and data sheet lookups and stuff like that somewhere about halfway down the page. It gets good silk screening too on the board. where we pulled that part out, where you can see the little melted piece there, is we got the emitter base and collector marked and the silk screen of the part. So we'll drop in replacement, real easy. Just got to find a piece that matches in my bin. So I'm testing this, what I think was a bad transistor, and I've got my multimeter set to diode test. That's one of these positions here, diode test. And essentially it just it reads on your meter whether or not you're getting a proper forward bias or not. And you can test from the base to the emitter, and from the collector to the base. And I won't go over all the testing. There's several other ways you can test these transistors, and maybe I'll cover that in another video sometime. But to the point of this video, this one's testing good. It actually isn't bad. And that stuff on the bottom that we thought was all bubbled up and boiled plastic, I was wrong. It was just some glue that got in there from gluing the case together. So this tests out fine. There's nothing wrong with it. So what else would keep that relay on hard? So let's take a look at the relay again. Nothing else really is controlling this. I've actually looked at the traces on the bottom. I followed the traces from that transistor, and that transistor does control this relay, and this relay is on all the time. So then the next thing is, well, is it on right now? And if you can look at it carefully on the video, there's the hot leg coming in here, and then the hot leg comes out on the other side of the relay. These should only be dead short when this is on. If it's on right now, and I've already tested this and it is, you'll hear that sound, and sure enough, that is a dead short through that relay. That relay is on right now when the circuit's not even plugged in. I mean, when I plugged in, it's on. So this is not an electronic failure of any other components except for the relay. This might make this a disposable product, because I really would like to find the exact relay, but because the specs are all on here, it's very well spec'd out. I may be able to find a relay that I can substitute in there, but my thing is I want it to be within the same exact specs, because I don't want this plugged into my house and not be at least better than what this one is and fit in here. And likelihood of me finding something that is actually going to drop in, replace this with as good a specs or better, without spending the cost of $6 to replace this, it ain't very high. If I find it and pay shipping, I'm down $6. So if I don't actually find something that I've salvaged, this is landfill farter, and that's all I can say. Okay, so that transistor was good, so we're going to put it back in. I just popped it back in, and then we're going to solder it back on the back side. Okay, clean my tip and my solder tinning. Clean it off in my brass. Heat that up, and this should go right back on the lickety split. Okay, now I'm going to take the relay off, and I've already looked at the traces and where the relay mounts. This point, this point, this point, and this point are the points that solder has to be taken off. And I'm going to try my mechanical plunger desoldering station. You get these for like $35. I have a link to them on toddfun.com under beginners for electronics. Make little circles and then pull it right out. But you got to keep these really clean or they just don't work. And there, just like that. There's our relay. Pops right out. And of course we have specs, so we can see if we got a replacement. And now that the relay is out of there, we shouldn't get any short between this hot leg coming in and going out anymore. So that's the short that you would hear if it was shorted. And nope, it's not shorted no more. Okay, so this is the relay that's inside, and this would be where the one hot leg is, and the center tap here is the other hot leg, and they should only be connecting from here to here when there's power across the to turn the relay on, like 24 volts on. So if I measure the short, if I measure between this center tap and here, if it should be an open, but the failure is it's going to be a short. Yeah, see, you're getting a short there, and this should not be a short across those two legs. That means this has definitely failed internally. Okay, this the relay. As we said, it's bad. I went to Octo Parts and Find Chips and even tried data sheets, like all data sheets and data sheet catalog, and I couldn't find this. But just a straight up Google took me to some, I think it was some Chinese site that actually did have sort of a embedded data sheet. So I did learn more about it. It is a single pull, single throw. On the back side, this pin and this pin is for the coils, and it's activated, of course, by 24 volts. We already know that from the printing on the front, and that makes a connection from here to here when the coil is engaged. But of course, this is on all the time right now because it must be fused inside. So when I typed in, of course, we already had a lot of information about this. We knew that it was 15 amps and 125 volts AC is what it could handle for switching. And if you wanted to use a DC configuration, you had 12 amps, 28 volts is what it could switch. And because of this name, we already kind of knew it was 24 volts coil DC, and it is. Find a 24 volt coil activated. Doesn't really matter if it's single pull, single throw, as long as I can pull it open and make a contact. And as far as amps are concerned, I'm really not concerned with the 15 amps. I think I'm just going to go for what I know my lights are. My lights are going to be way down lower than that. Let's see if I can find something in my junk bin where I can use. Well, it won't have this level, but if I do use something that isn't 15 amps, then I'm going to label this product. I'll just go ahead and label the outside of this that what the max is. I'll just get a marker that can write on this, and I'll know that this one has to be used just for Christmas lights. Well, try as I may, I went through everything I got that would, all of my spare parts and anything that I normally keep around that for a rainy day that I can tear apart and salvage off of. Nothing had a suitable relay that could substitute in this case. I'll put this on my order list someday when I make a bigger order. Justify the shipping when I'm buying something else more important. Cut the skull cap off this thing and see what it looks like inside. Recommend having a Dremel tool around the shop. This is really nice sawtooth, cuts plastic without melting it so bad, and of course a wand style is better for jobs like this. So let's have at it. There we go. Looks like we got the skull cap off. There we go. And we knew that these two outside ones were for the coil to engage this, and that's the inside. And you can see that it is fused shut right there. If I give it a push, it'll probably break loose. Right there's the is the contact points. It broke loose, and now it's loose again. So now it will go up and down. See, it moves. Click, click. Yeah, click. And so it was you can see it's melted in there a little bit where those contacts are fused together. Coil looks decent. Okay, I got a little piece of metal sandpaper. Kind of folded it so there's two sides to it. Got it jammed in there. I got all the crusty stuff off already, and now I'm just gonna slide that in and out and clean those contacts. And really they're supposed to be coated contacts, so I'm actually kind of filing off the coating, but the coating was already burned. But this will essentially make those surfaces, decarbonize those surfaces, and I'm just applying a little pressure to the contacts come together and rub on that sandpaper. And it's pretty fairly cleaned up in there now, and it still switches. And this, yeah, I'll make it work, but I ain't gonna put it in service. Okay, I got the relay taped on the other side so I can get to the pins to solder them on, just as clean up my tip. So this is just so I can prove that nothing else is wrong with this board. If I can put this repaired relay back on and everything's working, then I know that I can replace it for a little over a couple bucks. Okay, that relay's back in there. So is that transistor that we thought was bad. It should all be functional now, so let's give this thing a test. Okay, this is soldered back on, it's back together again. It's not glued together because I do have to replace that with a perfectly brand new relay. But we're in off mode right now. It says off, and now when we turn it on, that's my radio, because this is plugged into my radio. And if we go to any of the dark settings, then at dusk, these are all dusk, and then for how long to be on after dusk. If I cover the photo transistor, wait a second or two, the radio should come on. Oh, there it goes. And now, of course, we can turn off again. So that's it. Just the relay. It wasn't the transistor. It was the relay. Well, there. I hope that was helpful in learning how to troubleshoot something. It wasn't what I originally thought it was going to be. Yes, it's working. It's fixed, but not permanent. I will be replacing that relay with a brand new relay that's up to par before I actually glue this thing back together and put it back into service and keep it out of the landfill. So there you go. Hope it was fun. Hope you learned something. Thanks for joining.